Hey guys, the aim of this video is to explain what torque is. So let's go through an example over here on the definition of torque. So let's say we have a door over here. We treat this point, the hinge, as the pivot. So this is the top view, and we can think of the door as a lever arm, and we have a force when we try and open the door. So this is F, the applied force. And we're also interested in the perpendicular distance from the force to the pivot point, so that would be this line over here. And we call this R perpendicular. So together these two parameters give us our torque, which is this force times perpendicular distance from the pivot point. We can also think of this experiment in a real life situation when you try and open the door. If you try and open the door and try and push it from over here, you would find that it's much more difficult to actually open the door from pushing it here with the same force as here. And if you try and apply a force to the hinge of the door, you will find that the door will not even move. And this is because while the force is the same, R is now 0, the distance from the pivot point. So you're basically applying 0 torque to the door. Likewise, if you apply a force over here, remember our definition for R, it must be the perpendicular distance. So if you apply a force into the hinge, you will find that there's also no rotational movement because the force is acting on the line of action, so parallel to the line of action. So these two cases, one force here and another force here, would yield 0 torque. So let's go through this example with some numbers. Let's say we have 5 newtons here, and this door is 0.75 meters. The torque is quite simple to work out. The torque is now just F times R, so 5 times 0.75. And this works out to be 3.75 Newton meters, which is the units for torque. Again, let's quickly work out the force acting here. So same force, 5 newtons. And this distance, let's say, is 0.2 meters now. So our torque in this case would be 5 times 0.25. So this would be 1.25 newtons meter. As you can see, the rotational force when applying a force closer to the pivot point is much less. And you can also try this experiment on a door that you have in your house. Try pushing it closer and closer to the pivot point. You'll find it's much harder, and if you push exactly on the pivot point, you would find that you have 0 torque, which means the door will not even rotate this way.